Welcome to The Explainer. Today, we're diving into one of the absolute bedrock rules of our universe, but also one of its greatest puzzles, the speed of light. Why is it a constant, and why can't anything break it? It's a journey that's going to challenge how you think about reality itself. So, let's start with what seems like a ridiculously simple question. Are you moving right now? You're probably thinking, no, of course not, I'm sitting still. But what if I told you the real answer is, well, it kind of depends on who's asking. This one question completely blew up our understanding of the universe. So here's our game plan for getting to the bottom of this. We're going to start with the motion we all get, the everyday stuff. Then we'll see how light just completely shatters those rules. After that, we'll dive into Einstein's wild solution, tackle a seriously spooky quantum mystery, and finally, see how this ultimate speed limit is all about protecting one thing: cause and effect. Okay, first things first, let's talk about the old rules. For hundreds of years, the way we thought about motion was really simple, really intuitive. It's based on what you and I experience every single day. This idea is called Newtonian relativity, and the core of it is you just can't feel smooth, steady motion. If you're not accelerating, not hitting any bumps, not looking out a window, you feel like you're perfectly still. Right, this is Einstein's famous thought experiment. And the coolest part is what he said about it. It is just as scientifically correct to say your car is standing still and the entire world is zooming past you. Wild, right? Without some outside landmark to compare to, both points of view are totally valid. All motion is relative. And that principle was basically the foundation of physics for a really long time. But then we discovered something about light. And that discovery threatened to bring the whole building crashing down. Okay, so here's the huge difference. Most waves we know, like sound or water waves, need to travel through something. Sound needs air, ocean waves need water. But light? It's different. It's an electromagnetic wave, and it needs nothing. It can travel through the total, absolute void of empty space. And that created a massive problem. I mean, if there's no medium, no cosmic wind for light to travel through, then light should just be this fixed beacon in the universe, right? We should be able to measure our speed against it and finally detect our true, absolute motion through space. This was a full-blown crisis in physics. Either that core principle, that you can't detect steady motion, was wrong, or everything we thought we knew about light was wrong. So scientists went and did the experiments, and the results were just bizarre. No matter how the Earth was moving or in what direction, the speed of light they measured was always the same. The old rules were definitely broken. So to fix this giant paradox, a young Albert Einstein didn't just tweak the old rules. No, he threw them out and started over, building a whole new vision of the universe on top of one totally radical idea. He basically took that weird experimental result and said, that's not a puzzle. That's a law of nature. The speed of light, he declared, isn't relative. It's absolute. It is the one constant, c, for everybody, no matter what. But wait a second, how is that even possible? If you're on a spaceship going at 90% the speed of light and you turn on your headlights, how can you and someone on Earth both see that light beam moving away from you at the exact same speed? Well, for that to work, our old ideas of fixed space and fixed time had to go. They had to become flexible, merging into this one interconnected thing, space-time. And this is where things get really, really weird, but they've been proven to be true. To someone moving fast relative to you, it looks like their clock is ticking slower. That's time dilation. And unbelievably, objects moving at high speeds actually get squished a little in their direction of motion. That's length contraction. So here is the absolute key takeaway. The universe doesn't really care about giving everyone the same ruler or the same clock. It sacrifices all of that. Space and time will literally stretch and shrink for different people, all to protect one single unbreakable law, that the speed of light is the same for everyone always. All right, so physics had its new speed limit. Everyone was starting to get their heads around this bendy, stretchy space-time. But then an even stranger puzzle crawled out of the quantum world, one that seemed to just laugh at this ultimate speed limit. It's called quantum entanglement. And Einstein himself was so bothered by it, he was the one who famously called it spooky action at a distance. He just could not accept that this was how reality worked. So here's the gist. You can create two particles that are deeply connected. Say you know their combined spin has to equal 0. Now, you send one to the other side of the galaxy. The moment you measure your particle and find its spin is up, you know instantly that its partner's spin is down. That connection, that influence, seems to happen faster than light. So this leaves you with two seemingly logical options. Option A, the particles are somehow sending secret signals to each other faster than light. Or option B, it's not spooky at all. It's like putting a left glove and a right glove in two separate boxes. You open one, see the left glove, and you instantly know the other is a right. The information was decided from the very beginning.
But this is the absolute mind breaker of quantum mechanics. The real answer is neither. It is not faster than light communication. And, thanks to incredible experiments based on Bell's theorem, we know for a fact it is not predetermined like the gloves in the box either. Reality is just fundamentally stranger than both of those common sense options.
So if it's not secret messages, and it's not a pre-decided fate, how in the world does the universe allow this spooky connection to exist without completely destroying its own most important rule? Well, the answer, the thing that saves the cosmic speed limit, is a beautifully elegant idea in quantum physics called the no communication theorem. And here's the beautiful loophole. Yes, the correlation is instant, but when you measure your particle, the result you get, up or down, is completely and totally random. You can't force it to be up to send a 1 or down to send a 0. Your partner's particle instantly flips to the opposite state, but since your result was random, their result looks random to them too. They have absolutely no idea you've even made a measurement until you call them on a regular, slower-than-light phone and tell them. So, at the end of the day, the universe is full of these weird, instantaneous, non-local connections. But it has this perfect built-in safety lock. It absolutely forbids you from hijacking that spookiness to send a message and break causality, to make an effect happen before its cause. The cosmic speed limit for information holds. And this whole journey leaves us with one last, kind of dizzying thought. We started with something as simple as, am I moving? And we ended up in a universe where time and space bend, and spooky connections span galaxies in an instant. It really makes you stop and wonder, what other huge, fundamental things about the world around us have we just completely misunderstood?